Well, good morning, everyone. Today is Wednesday, March 25th, and here are your learning targets today. Math board, I would like for you to work in fractions. I'll show you where. Next target, problem set 5 in your math packet. Today we'll be making equivalent fractions. And in iTunes U, still with Earth features, you're going to learn more about the rock cycle. In MathBoard Fractions, I'd like for you to continue practicing on parts to fractions, and then I'm thinking that you can compare fractions. Remember the rule: 2 times 1 is 2, 3 times 1 is 3, 3 is bigger than 2, so 1/2 is bigger than 1/3. All right. You can also check out simplifying fractions. That might be a little tougher, but I will be doing a lesson on that soon. Then in iTunes U, you're going to go into your fossils and rock formation. Check out media. I'll slide over and show you what's in there. In media, please note all of the blue check marks that I have already done. These are all the lessons that have previously been announced. Today, you're going to watch the rock cycle video. Then, you'll go back and then check out in learning about rock fossils and rock formations. That's this screen here. You're going to put a blue check mark here. Earth floor, rock cycles. Read on epic rocks and minerals, the rock cycle, and then the rock cycle diagram. Okay? Make sure when you're done, you put a blue check mark on all of those. And have a great day. And now today's math lesson. This is going to be getting you prepared for problem set 5 in your math packet. All right, a little review first. I'm going to look at 5/6. First of all, I need to make 6 equal parts because my denominator here says to make this one whole fraction bar, that's the number 1, into 6 equal parts. And then we'll shade 5 of them. Okay, so for me to make 6 equal parts, I start by making thirds. Take the thirds and cut those in half, and that would make your sixths. Okay, now to represent 5/6, I'm going to shade 1, 2, 3, 4, and 5/6. Okay, as a reminder, 5/6 can be decomposed as 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1 more sixth. All right, let's take a look and make sure. 1/6 plus 1/6 plus 1 more and 1 more and 1 more is a total of 5/6. So let me rewrite this as a multiplication sentence because repeated addition can be converted to multiplication. So 5/6 is equivalent to 5 times 1/6. All right, let's do another one for an example. Let's take a look at 5/8 this time. So looking at 5/8, I'm going to break this up into 8 equal parts. I do this simply by making halves, then turn the halves into fourths, and then turn the fourths into 8 equal parts. Now the denominator is 8, so I've got 8 equal parts. The numerator is 5, so let's shade 1, 2, 3, 4, 5 out of the 8. 5/8 being represented here. All right, we're going to change this into decomposing the 5/8 as 1/8 plus 1 more 8 plus 1 more 8 until we have a total of 5 of those. Let's verify that we do. 1/8 plus 1/8 plus 1 more, and we do. All right, so let me rewrite 5/8 as a multiplication sentence that is equivalent to 1/8 5 times. So 1/8 times 5 equals 5/8. Send me an email. Some of you have done. Okay, so now let's get into making an equivalent fraction. Here you can see I have a fraction bar that is representing 1/2. So my numerator is 2 currently. So that's the 2 equal parts of my fraction bar. 1 is my numerator, so that's representing 1/2 here is shaded. Now I want to prove that 1/2 is equivalent or equal to 2/4. Okay, so how will I do that? I need to make sure that my fraction bar, which currently has 2 equal parts, can now make 4 equal parts. I'm going to do that by making one line which makes 2 rows. Notice that I have 2 rows here. Okay, I'll point them out. We've got 1 row and a second row, 2 rows. Now take a look at how many equal parts I have. If I count, I have 1, 2, 3, 4 equal parts. So I change this to my new denominator, 4, and the same region has 2 out of 4 shaded. So 1/2 is equal to 2/4. Let's do another one here. All right, this fraction shows 1/3. My numerator is 1 shaded out of 3 total equal parts. All right, in this case, I want to prove that 1/3 is going to be equal to 2/6. How can I do that? Well, I'm going to change my thirds into sixths. Let's verify. 1, 2, 3, 4, 5, 6. I now have 6 equal parts. That same region, which was 1/3, now has 2 out of 6 shaded, which is equivalent or equal to 1/3. All right, I'm going to erase this and show you another conversion I can make, another equivalent fraction. So again, I'm going to start with 1/3. This time I want to prove that it is equal to ninths. Okay, so how can I make ninths? I'm going to make, this time, instead of 2 rows, I'm going to make 3 rows here. Okay, so you can count the 3 rows. There's 1, 2, 3 rows. So that region which was 1/3, now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 equal parts. So I am working with ninths now. And if you look at that same region which was 1/3, you can now say it is also equivalent to 3/9. Okay, so that's going to help you understand our next part, Call Me Up, which is draw an area model to illustrate 1/5 is equal to 2/10. All right, so first I'm going to draw 5 equal parts because my denominator here is fifths. So I'm going to make, best I can, 4 lines. 1, 2, 3, 4 lines will make 5 equal parts. Let me verify that I have fifths. 1, 2, 3, 4, 5. I do. So to show 1/5 means I'm just going to represent 1 out of the 5 parts. 1/5 is shaded. Okay, so how can 1/5 be equal to 2/10? Well, in this case, I can draw one line making 2 equal rows, and 1/5, which I started with, now by drawing that extra line in there, I've made 10 equal parts, and that same region that was 1/5 is now 2/10. And as always, you can, let's do one more. Decompose 1/3 as 4/12 represented in an area model. Okay, so I'm going to start by making thirds. The fraction 1/3 can be represented by highlighting 1 out of the 3 parts. So I have 1/3 being represented here. How can I change those thirds into 12ths? Well, I'm going to need 4 rows in this case. So 4 rows. 1, 2, and this line makes 2 more rows. So let's count that we have 1, 2, 3, 4 rows. At first I started with 1/3 shaded. That region which was 1/3 now is equivalent to 4/12. That's our area model to prove that. The examples, let's get into today's lesson, problem set 5. It says to draw horizontal lines to decompose each rectangle into the numbered rows as indicated. Use the model to give the shaded area as both a sum of unit fractions, that means to add them up, and then we'll make that a multiplication sentence. All right, I'm going to zoom in on this example here. You can see at first, if you thought about this dotted line not being there, you would have, if you could omit that, take it away, 1, 2, 3, 4 parts. And 1 out of the 4 parts is shaded. So we have, without that dotted line there, we have 1/4. But by putting that dotted line in, we have created 2 new rows. 2 rows. So now we have taken the 4th, which we originally started with in this picture, and by making 2 more rows, we now have 1, 2, 3, 4, 5, 6, 7, 8 parts. So over here, I'm going to label this as 2/8, because what started as 1/4, by drawing this line, now we have 2 parts shaded out of a total of 8. So 1/4 is equivalent to 2/8. We're going to show 1/4 as a decomposition of eighths, so that 1/4 really is 1/8 plus 1/8. So over here, I'm going to write 1/8, which is already done, plus another 1/8, which equals 2/8. All right, now let's turn that into a multiplication sentence. 1/4, which we originally started with, if you took that dotted line away, is equal to 2, you can see them, 2 times 1/8. So I have 2 1/8, which equals 2/8. Okay? You'll do that for B and C. Here are your hints. Here you're starting with 1, 2, 3, 4, 5. So you start with fifths, but by making one line, you will then have 2 rows, which turns those fifths into tenths. All right, let's go to the back side of your paper today. Problem set 5, 2A. Drew my model of an area. I'm going to start with what the first fraction says, 1/2. So I'm going to make 1/2 first. And I'm going to shade 1 out of the 2 parts. Let me use my highlighter instead. So 1/2 is being represented. Okay, so I have 1/2. I'm going to show that 1/2 is equivalent to 3/6. That means I need to take my 2 equal parts and turn them into 6 equal parts. I'm going to do that by making that and that. So I made 3 rows there. You can see 1 row, 2 rows, 3 rows. Now I have 1, 2, 3, 4, 5, 6 equal parts. So let's write a sum of unit fractions. So 1/2 is equivalent to 1/6 plus 1/6 plus 1/6. To continue writing that sentence, we could say 1/2 is equivalent to 3 times 1/6, which equals 3/6. So that goes back to the original sentence here that we started with. 1/2 is equal to 3/6. You can always review this tape, rewind it, check it out. If you misunderstood it, listen to it again. I'm going to go back, or all the way to the bottom, number 3, the last problem. We're going to explain why 1/12 plus 1/12 plus 1/12 is the same as 1/4. All right, let me show you this. I'm going to start by making 1/4. So I'm going to make a model that starts with 1/4 here. There's 1/4. Now let me prove that 1/4 is equivalent to 3 of these 12ths. So to do that, I need to turn these fourths into twelfths. I can do that by making 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I could draw that a little more equal here. There we go. Okay, so let's count. Did I have 1/4 to begin with? Yep, I drew one part shaded out of 1, 2, 3, 4. But by making 1, 2, 3 more rows, I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. And of those 12 parts, you can see 1/12 plus 1/12 plus 1/12 is shaded. That's equivalent to 3/12, which is equivalent or the same as 1/4. So to explain that, I would say, first, I represented 1/4. Then, by drawing 3 rows, that same region became 3/12, which can be decomposed as 1/12 plus 1/12 plus 1/12. All right, boys and girls, you can always review any part of this. You can even go back to